tell us a little bit about yourself. What do you do, and what's your background?
Okay, so my name is Hrishikesh Kamat. I'm 32. I'm based out of the city of Pune in India.
Hmm.
By education, I'm an electronics engineer. I run two startups, one by the name Shalaka Connected Devices, the second by the name IoT Adak. Uh, Industries today, if you see, they need a lot of technology help. And it is no more limited to software. So if you look back a decade back, it was all about IT solutions for industries, IT solutions for logistics, and so on. But now electronics is being the core of most of the things that we do. So your cars are being more and more bombarded with new electronic features. It's no more a mechanical strong foot. You have your home automation system coming, you have security systems and whatnot. You have small variables and everything. It was a distant dream 20 years back. So that exactly is what we do. So companies approach us with a problem statement, an idea, an existing product that they have, or maybe some kind of a hardware they want to integrate with their software platform, like various data logging systems, maybe a automated IoT based energy meter, water meter, steam meter, and so on. So our job is to get on the design table, think how to do it, figure out the hardware, do the circuit design, write the firmware or the code that goes for those electronics devices, and get them ready for production. So it's a long journey, but we specifically look at ourselves as an extended R&D team. That's how
Yeah,
I coin it.
this is
So
so
we want
interesting.
yes.
Because my background is that apart from what I do here on the podcast, I spend my time. We have a company and we manage Amazon brands and e-commerce, and a lot of our clients, they are basically getting products manufactured mostly in China, many times in India, Turkey, other places, and then selling them online. But yeah, I can see actually a great need for a service like yours, because a lot of times they would get items manufactured, they would get the products developed and manufactured by the same company, which is the manufacturer, which might be great in manufacturing and have a great production line and everything. But in terms of the actual innovative design and IP of the product, I think it might not be the best fit, because then you end up with a product that is exactly the same as 10 other sellers, and the only difference is the label on it. So, tell me about a bit about what you do in terms of. Um, so, if someone came to you, how does that process work? Would they just come to you with an idea? Would they come to you with a product that needs improvement, or how does it work? A typical kind of a project.
Okay. So we have different personality of customers. I
Hmm.
call them personality because they come with different backgrounds. So one is they would be coming with an idea. So it's something out of the blue, or it's maybe something that is still in a research mode in many places, or maybe a kind of a twist in an existing product that they don't have. It's manufactured by somebody else. They want to improvise it. So it's an idea to product journey. Some brands come to us with an existing product.
Hmm.
They want bug fixes done, or they want a new feature added. It depends, because a large brand, if they have to deal with, let's say, 5 or 7, 10 bugs, which is a 3 month job, let's say,
Yeah.
then the amount of money they have to put in getting a team in house, with all the large number of human resources they would have, it's very easy for them to pay a smaller company and get things done. So that's what we leverage on. Then we have companies who come to us with a competitive product, and our job is to analyze the product. I won't call it reverse engineering.
Hmm.
Our job is to analyze the product and look at a version 2 of the product. So we are always one step ahead of the manufacturer.
Yeah.
And a unique type that I have is they come with a problem statement. This usually happens with industries. So let's say there's a manufacturing industry, an automotive industry, or something. They are a full running business, but they want something that can improve their operational efficiency, or maybe they have a very peculiar problem for which there is no product in the market. Like for example, one interesting use case was, so
Mhm.
milk is collected in small villages, and
Yeah.
then there is a milk van that goes to every village and collect the milk, and they get it back. But sometimes the quantity of milk is not economical that a truck or a milk van goes all the way to that village, collect it, and get back. So a company has designed chillers that can store the milk for 48 hours. So it's a cold storage unit with a stirrer and everything. But then there was theft happening. So they tried the typical thing of weighing the milk and finding out. But if you swap it with water, let's say I take out 2 liters of milk and put in 2 liters of
Yeah.
water, you can somehow manipulate it.
Yes.
So our solution was, we built a pressure sensor that takes the pressure inside the unit. So, and which had high accuracy as compared to what your regular load sensors give you, because there are thousands of liters of milk. It's not 10 or 20. So the small resolution of weight change or pressure change that we need to understand, we needed something that is precise to 1 liter or 1.5 liter, whereas these weight sensors could behave somewhere by 50, 100 liters of change. It's only when you take out 50 liters do you see that something has changed. So these are the kind of unique problems that we have to deal with. I mean, there's no product in the market, but then we built it for them. They are now selling it to their competitors, so it adds a revenue stream to them, because it's a common problem. If they don't sell it, somebody may get it designed outside. So might as well have an additional revenue stream. So these are the kind of problems that we have to deal with, which is a very interesting set of customers. Now,
Yeah.
when they
Mhm.
approach us, we first have two kinds of analysis done. One is what I call a technical analysis and a financial analysis. Now, sometimes uh, uh, the product they want to build, they have very high technical specs that may not be achievable at a certain cost. So if I want an expensive sensor, or if I want to run some expensive, let's say, ML algorithms on my system, then my hardware needs to support it, and that comes at a price for a volume. So
Mhm.
we are talking volumes and price. So we do this technical and financial analysis for a customer at their start, so that they are confident when they hit the market, because they would be typically looking up for ingredients or the components online, and they would do a rough calculation. But there are a lot of losses that happen. You need to take into consideration, and a manufacturer to manufacture ships it out to you, the plastics that get inside, certain regulations that you have to think about. So for example, if I have to go for some kind of a certification, the certification cost needs to be added on the product. So,
Mhm.
so these thought processes may or may not be there. So usually, my team sits with the customer, understands the financial and technical aspects, and then we give a proposal of a time, number of resources, what we would need, what we have internally, what support we need from outside. So testing agencies, or maybe you have domain experts. So let's say I'm working on a let's say an automotive equipment. I need to have somebody from that industry to help me out. Because as an engineer, I know a certain level of engineering, but domain specific is what needs. So we collaborate with these people and give a complete project cost. So number of resources, time, resources in terms of material and man, and that's when the execution starts. There are some projects which are completely research oriented. I mean, it's very hard for me to say, okay, we'll give you a product in 6 months. So we need to look at what the customer wants, what are his benchmarks for a good result. So sometimes they just tell me, okay, you have to try it, and if it works, we will build a product around it. So it's similar to research
Yeah.
grants that universities get. So we do take up those activities with a different mindset altogether.
Mhm.
And then once we get on the work, then we have the hardware team working on the hardware, the firmware team working on the firmware, the cloud, the mobile app, the teams coming in based upon what's needed. And at the end, we give maybe 5 prototypes, then about 50 or 100 engineering samples. We can test it out. It depends on case to case. If it's an expensive product, it will be just 3 or 5 engineering samples. If it's a commercial good, it may be hundreds of samples for the customers to test. And once we have a checkbox that it's working as they're expected, or if there are to's and fro's, you need to change some specifications because of last minute challenges or whatever. Once that is done, we hand over the IP, or we have a shared model. The costing depends upon customer to customer, but that's when it goes into production and then it goes out.
Yeah.
So this is the entire product life cycle.
Mhm.
And there are cases where I have to support on the journey of the product. So your product life cycle starts at the ideation stage and ends at it become obsolete. So sometimes out in the market, you need to push an additional feature like an over-the-air update, or maybe there are bug fixes, so you need a version 1.1, 1.2, or something like
Yeah.
that. So we are like a team. We don't look at ourselves as a customer and vendor approach, but we look at ourselves as a partner, as a development partner, or as a extended research and development
Yes.
house.
Yeah.